So now we are going to talk about buffer overflow. So through buffer overflow, what is the possible attack scenario? Like there is a waveform, so you enter some data into it, then this waveform send this data to the server. Then what server will do? Server writes the data into the buffer without checking the input data. Okay. So what will happen? This data overflows from the buffer, and this overflow might enable an attack. Okay, so that's what we are going to discuss in this part. So if so, then this attack could be carried out by anyone with an internet connection. Suppose this is a this is a code, like there is some buffer, but what will happen if you try to write like buffer 20? If you use Java or some other language, in that case there will be some exception, but whenever you use C, it will do nothing. I mean, there will be no error in this case. So you may think about why to use C, because till now many system is running in C. Many legacy software are in C, so you cannot just remove C from this world. Okay, still people are using C. So what will happen here? Depending on like what will happen if I execute this course. Okay, so maybe in buffer 20 there might be some other values, so that may be overwritten, or might be there are some system data that could be overwritten. Okay, or the program could just work fine. Okay, so let's take a look how actually buffer overflow work. So suppose this is the buffer. Okay, this is the buffer, and some part of the buffer there is a boolean flag, like to authenticate someone, so that is false. But if this buffer overflows, I mean this buffer is full, and you can put some other things, and you just put T here. Okay, so in that case what will happen? This authentication value or this boolean flag is changed because the buffer is overflowed. Okay, so now that means that user is authenticated. Okay, so there should be some so first condition is there should be some overflow, and the overflowed area, there must be some important part in this overflowed area. Okay, okay, so let's think about this memory organization. So how actually this memory organized? So suppose this is our memory, so some codes are in this area. Sometimes we use static variables which can be added in data, and the dynamic variables, they are in heap area, and there is stack, so there are some stack pointer. Maybe in operating system you have to learn these things. Okay, so there are some like low address, high address, and this stack pointer, it just move up and down. Okay, so what will happen here, like we have like a function integer a b, so there is a character buffer, a void main or some. Okay, so what will happen here, it will put a b into the memory. Okay, so this main function, it is calling function 1, so it goes to the function 1. So in function 1 there is two integer a b, that is 1 2, so integer a, integer b. Then what will happen, this function will return something. Okay, so that means it will come back here again, like, so there is a memory address there, so it will go to that memory address, and that again it start executing. Okay, so this is the stack pointer. Okay, so everything is fine. So we have this return address here. Okay, but what happened, like if truly overflows the buffer, so this buffer is overflowed, and with some suppose some random bits. So what will happen, the buffer will overflow that return value area, right? So in this area there's supposed to be a return address, but now there are some different value. Okay, so the the function might crash. Okay, because it was supposed to go something some like in this place. Okay, but now because of this overflow the value is different, so we actually don't know where it is pointing. Maybe it is pointing some other place, there may be some garbage value. Okay, and but Trudy might have some new better idea, right? What will he do? He will use some evil code. I mean, this is a code injection technique. So in the stack, it will add some evil code. Okay, and he somehow he changed this value so that it will return to this evil code. Okay, so it is possible, right? So you can just change the address here and put the address of this evil code. So what will happen, this evil code, maybe there are some different queries or maybe some script you can run inside this evil code. And also sometime uh, Trudy can precede the injected code, evil code, with a knob. So knob is like a landing pad, because sometimes you never know where should we go. Okay, so in return value you just randomly put some value, and we you input knob or some nonce value. Okay, yeah, so what will happen, it will just execute this one, then execute this one, this execute this one, then it execute this evil code. Okay, so the thing is, it was supposed to do like this evil code, but it is not always possible to return in this code. I mean, you don't know the address, so whatever you do, it can return in there, it can return in here, it can return in here. So wherever it goes, it continues executing this course. So ultimately it will execute this evil code here. Okay, and also in return value also, you like the attacker, they don't know like which return value to override. Okay, so they might put the return value in several places, so it can goes from here, or maybe it can goes from here, so it depends. So if we summarize this stack smashing summary, so the first thing is this buffer overflow must exist in the code. Okay, not, it's not like every code you can just make some buffer overflow. It is not possible. Okay, so not all buffer flows are exploitable. Okay, so in that case everything should be precise. Okay, so the things should be lined up correctly, otherwise this buffer overflow won't be a issue. Okay, so whenever these overflows are exploitable, then attacker can inject the code. Otherwise, it is not possible for attackers to inject the code. Okay. So this stack smashing is the attack of the decade. Like in that time, C language was very popular. So in that case, I mean, people are just trying to find some overflows and trying to inject some code or makes the system behave differently. And also not only the previous last decade, in current decade also, still now whenever this kind of programming language is being used, like C, there is a buffer overflow. So let's see an example. Okay. So suppose Trudy is confronted with a program that asks for a serial number. Okay. So what will happen? You will put some serial number here. So, but Trudy, she don't want to waste his money in this system. Okay. So what will she do? And she don't have the access to the source code. Okay. So what will she do? So what Trudy will do? Trudy tries entering some unusual output. What will also do? Like just give some random value or something and see how this program reacts. Okay. So what Trudy will do? She will put some values, unusual inputs, so that the program will misbehave in some way. Okay. In that case, she might get a chance for exploiting the input incorrect behavior. Okay. So suppose she just put a number of A's as a serial of inputs. Okay. So and we will have some result here. So this result actually indicates that the program has a buffer overflow. Okay. And like you can see, there are some values here, 0, 4, 1. Okay. So this is actually a value for A, ASCII value of A. Okay. So that means there is 2A in some place. Okay. So in some place here, the buffer has been overflowed, and that is 2A. Okay. So if we just analyze the error message, she can overwritten exactly 2 bytes of the return address with the character A. Okay. So now what we will do, we will use a disassembler. In the exe file, if you disassemble USB file, exe file, you will get some code like this. Okay. So in this code, you can see the overwrite this address 401034. So we have the serial number here. Actually, it means the serial number is correct in this location, right? So she will have to obtain the access to the code without knowing the correct serial number. So if I come to in this place somehow, so that means I know the code, but I don't. So now we take that location, that return value, that location, and we take the ASCII value of that and input that ASCII value at the end of this series of A's. So we'll have this error again, and if you can carefully see, the byte order is reversed because existing processor what we use, it is little Indian, so we have to make it reverse. So this value should be reversed. So we reverse that value and we input this one. So what will happen? That serial number is correct. So that memory address value is being printed. That means that software is being, you get the permission for use the full version, maybe full version of the software. Okay, so this is how we can bypass the serial number. So for example, like if the attacker don't have the access, the source code, he can use a disassembler. Okay, so what is disassembler? It disassemble the exe file. You can try it by yourself also, and there are some machine code inside there. Okay, so what you need to do, you need to find out the address where to jump. Okay, if you don't have the reassembler or the exe file, you may try you may select some random address, maybe by error and trial process. You can just give something. If it is doesn't work, give another one. Okay, through that, it's kind of a brute force technique. Okay, so in this example you can see a simple C program. So what you need to do, if you have the source code, then easy, that's fine. If you don't have the source code, if you just disassemble this code, then maybe you need to find the address of this part. Okay. So if you know this address, so you can put some return value, maybe to jump to this address. So whenever this part is executed, that means your serial number is correct. So how we can prevent this stack smashing? Okay. So first of all, we need to find we can employ a non-executable stack. So the stack we have seen earlier, those are all executable. Okay. But if we can just make it non-executable, so in that case, the attacker cannot do any harm to the system. That is, we can use the NX bit, that is called no excuse bit. Okay. And we can use a canary. So canary, I think it's a bird's name. Okay, so I'll discuss this one later. And also the layout can be randomized, I mean the address layout. Okay, so whenever you run the program, it will choose the address randomly. That is called ASLR. Also, you can always use a safer language like Java, C Sharp. We don't have any buffer flow related error in Java or C Sharp, but if you use C, there is a possibility of having buffer overflow. And also, we can use safer C function. For example, you know this function strcpy, I mean string copy. Okay. So if you use string copy in your code, there might be a buffer overflow. It is possible. So in that case, we can use strncpy. I mean, you can define the number of n here, so that you just copy that desired number of bits. But in here, you can't do that. Okay. So this is unsafe, and this is a safe function. So we can use those also. So now let's talk about canary. As I said, this technique is being used for coal miners. The coal miners who take a canary with them in underground. So if the canary died, okay, in that case, the coal miners, they knew that there is a problem in the air. Okay, because it is underground, there are no oxygen or less oxygen, maybe some other gas also. So they put canary there. If canary died, that means something wrong. So they can alert themselves and they can get out from there. Okay. So that is the thing. Like this is we have this canary in this place. So if anything happened here or any overflow came to this position, that means this canary or this value is override. So if this is override, that means we kill, I mean attacker kill the canary. So whenever this value is not there, so that means there are some problem. Maybe there are some buffer overflow. Microsoft, they have its own canary there for this buffer security check. So it's kind of a like a error handler kind of thing. Okay, you can study more about this in the internet. This ASLR, so address space layout randomization. So it makes this attack probabilistic. because there is a randomization, so that means maybe the address vary from different run. Okay, whenever we execute a file, suppose, so it will uh, assign some memory address for that program. But if you just close that part and again rerun the program, it might move to some another memory location. So the memory location is randomized. So in that case, it will be difficult to proceed with buffer overflow attack. Okay. So this buffer overflow has been a security threat for a long time, and still we have this problem. Okay. So for this reason, we might use, as I told earlier, some safe language, NXBit, ASL, or canary, those things. Okay. But the thing is, legacy code is there, and also some bad practice in development. Just we can just run the program. Okay, if it is run, then we say it is okay, but we don't check the security issues there. So I think this problem will exist in future also.